Bismillahirrahmanirrahim. We will be covering line balancing problem. So, in Brewer book, that line balancing problem and examples are related to assembly lines. So, in today's video, we will discuss the basic things regarding the assembly line so that you should know the parameters that will be used in the line balancing examples. So, manual assembly line, as you all know that in most of the assembly setups, you have multiple workstations that are arranged in some specific sequence. Normally, you have a base component which enters the system. That base component is launched into the system and it goes to the first workstation where subassemblies are assembled on that basic frame structure. And then it moves forward to the next station. And in the next workstation, some of the more sub-assemblies will be assembled to the base part basically. And finally, you get a full-fledged assembled product. Normally, uh, assembly lines are organized to produce a single product or maybe a limited range of products. And as I said that you will have sub-assemblies and those sub-assemblies are normally assembled to the base component at multiple workstations. So each product in an assembly line will be consisting of multiple components. They are then joined together by various assembly work elements to come up with the final product. So there will be a terminology used with the name total work content. So total work content is basically the sum of all the work elements required to assemble one product unit on the line. Work content is basically the total number of operation that will be performed on a particular product. And work element is an individual operation. So, for example, if you have two components and you want to join them, so total work content will be the combined form of these two components. And the number of operations that are involved on that particular assembly operation will be the work elements. For example, if you are performing a joining operation and you, for example, want to join these two parts with the help of a nut and bolt operation. So, nut and bolt operation is a single operation in which you use a bolt and a nut to fasten two parts that you want to assemble. For example, if you want to join these two parts with, let us say, electric arc welding. So, electric arc welding is a single operation. Uh, so, the total number of operations will be basically considered as the work elements. And work content is the summation of all those work elements. So the total assembled product will be basically the sum of all the operations that will be performed on an assembled product. So let me start with the presentation so that you can easily see. So manual assembly lines, if you look into the configuration of that, so you have multiple workstations and they are arranged in a sequence and that sequence is normally equal to the uh, sequence of operations that will be performed. So whatever is the sequence of assembly operations, normally you will have that sequence of the workstations as well. So you will have a base component that will be launched into the system onto the main conveyor system, main transportation system of the assembly plant. It will move on to the first workstation, and there will be sub assemblies which will come through a secondary transportation scheme to individual workstation. So basically in assembly plant you have two types of uh, transportations mechanism. One is the main conveyor system, which will move the base part along the workstations, and other are the sub transportation schemes that will basically move individual sub assemblies to individual workstations. So normally the base part, the base component will reside on the main conveyor mechanism that will transport the workpiece to a specific workstation, and a sub-assembly will be assembled to that part, and then it will move on to the next workstation, and finally you will get the assembled product. The production rate of an assembly line will be determined by the slowest workstation. So that was discussed in the previous video, in which we were discussing the blocking and starving phenomena और स्टोरेज बफर का जो टॉपिक हम डिस्कस कर रहे थे, दैट आई टोल्ड यू that a workstation which will have the maximum processing time, or if it is an assembly plant, so that will be assembly time. So any workstation whose processing time or operation time uh, will be the largest, so that will decide the production rate of the system. So if you have a workstation with largest processing time, this means that that particular workstation will be the slowest workstation. So slowest workstation means the workstation or the machine having the maximum machining time. Maximum machining time means that it will be the busiest workstation of the system. You know? So that slowest workstation phenomena will basically decide the cycle time of the system, and cycle time is normally uh, that time in which you will get one finished part out of the system. Either it is an assembly plant or a production plant. So the production rate, or you can say the cycle time of the system, will be decided by the slowest workstation. Slowest workstation means the busiest workstation, और busiest workstation या slowest workstation को bottleneck station भी कहा जाता है. So in the problem statement, either the slowest station will be mentioned or bottleneck station या busiest workstation का जिक्र होगा. So you must know these things. Assembly workstation is basically वो एक वर्कस्टेशन की जब आप बात करते हैं एक असेंबली सिस्टम में, so it is basically a designated area for one or some of the workers who work along the sub assemblies and the main component, and they normally perform some assembly operations. So Assembly workstation is basically a designated location along the workflow path at which you will see one or more work elements that will be performed by one or more workers. Uh, Here is a list of products that are normally assembled through the assembly lines जिसमें automobiles आपके आ जाते हैं, cooking ranges, dishwater dryers. ठीक है, so just go to these listing. मैनुअल असेंबली लाइंस में दो चीज़ें आप देखेंगे. एक तो ये है कि जो प्रोडक्ट्स हैं दे आर असेंबल्ड एज दे मूव along the line. And at each workstation, some portion of the total work content will be performed on each individual unit. वर्क कंटेंट मैंने आपको बता दिया है कि जो टोटल नंबर ऑफ ऑपरेशंस होंगे, so some ratio, some percentage of that total number of operations will be performed at individual workstations. And you will have a base component that will be launched onto the beginning of the line at regular intervals. और वो रेगुलर इंटरवल जो है वो आपका साइकिल टाइम. For example, if the cycle time of the system is 10 minutes, so 10 minutes cycle time means that after each 10 minutes, you will get one assembled component from the system. And after each 10 minutes, one base component will be launched into the system because it will be a continued operation. ठीक है ना. सो हर 10 मिनट के बाद एक बेस कंपोनेंट जो है वो इंटर होगा सिस्टम में, और हर 10 मिनट के बाद एक फिनिश प्रोडक्ट, एक असेंबल्ड प्रोडक्ट जो है वो आपको असेंबली लाइन से मिलेगा. And during that cycle time, workers will add components progressively to build the product. Here is a list of some assembly operations that normally you see within an assembly systems. So, चूंकि assembly operations है, so most of the operations may be adhesive operations, sealant applications हो सकते हैं, arc welding होगी, spot welding होगी, electrical connections होंगे, press fitting, etc. Yeah. So, all the joining processes to join two parts will be part of the assembly workstations. Joining processes where they are basically of two types. You can have permanent joints, you can have temporary joints. So the operations related to permanent fasting as well temporary fastings will be the key components of an assembly plant. लाइन पेसिंग का जिक्र जो है वो आ सकता है क्वेश्चंस में. तो लाइन पेसिंग इज बेसिकली द स्पीड ऑफ द assembly line. So line pacing will be decided by the cycle time of the system. So if for example the cycle time is 5 minutes, so this means that the pace or the speed of the assembly line is 5 minutes per part. So मैनुअल असेंबली लाइन जो है नॉर्मली इट ऑपरेट्स एट अ सर्टेन साइकिल टाइम ऑन एवरेज बेसिस जब आप उसको कंपेयर करते हैं. सो ईच वर्कर must complete his assigned task within that particular time. For example, if cycle time, as I said, is 5 minutes, so a part will come into the system into a designated area, which will be a workstation. For example, ये आपका workstation है जिसमें दो रोबोट्स या लेट अस से सिंगल रोबोट जो है वो एक स्पॉट वेल्डिंग का ऑपरेशन जो है वो परफॉर्म कर रहा है. So the base component will come on to that particular area, एक वर्क स्टेशन पे आएगा, and for the, let us say if the cycle time is 5 minutes, so each worker must complete their task within that 5 minutes. So after 5 minutes, that part will be switched to the next designated area, which will be another workstation. So ये cycle time जो है, it basically provides a certain pace to the system. कि अगर 1 minute है तो after each 1 minute all the worker should have completed their respective operations जो भी वो assembly operations perform करेंगे. So pacing provides a discipline for the assembly line workers that basically guarantees a certain production rate of the product. Pacing जो है वो different types की हो सकती है. Again, I will just give you a brief idea about pacing also. कि pacing की जब आप बात करते हैं तो it can be rigid pacing, it can be pacing with margin, or you can have no pacing within the system. So ये animated figure जो आपको नज़र आ रही है, so it is an example of the rigid pacing. Rigid pacing में ये होता है कि if it is an automated system or manual system, in both scenarios, we will talk about, let us say, a manual system. So in manual system, worker will be standing in their respective designated areas. The base component will arrive that area, और उस एरिया को हम वर्क स्टेशन ही कहते हैं. ठीक है ना. सो असेंबली लाइन में अगर फॉर एग्जांपल कोई मैनुअल ऑपरेशन हो एंड देयर इज़ अ वर्कर who uses some hand tools to assemble the product, so that worker himself will be designated as a workstation. So if you have a worker, so the base component will arrive his designated area. He will start assembling things on the base components, and suppose 1 minute is the cycle time, so after each 1 minute that part will automatically move on to the next workstation. So during that 1 minute the worker must complete his task. That is a rigid pacing. That the worker will stand in his designated area, the workpiece will come into that area it will stay in that particular workstation, and that stay will be the cycle time. And suppose if it is 1 minute, so it will stay in that particular workstation for 1 minute. In that 1 minute, the worker must complete his task. And then it will move on automatically, because the base component will be residing on the conveyor system, on the transportation scheme. Another discipline is pacing with margin. Pacing with margin जो है, normally it is adopted by those types of industries in which the size of the product जो है वो बड़ा हो, like automobile industries. So in automobile industries you might have seen that the base frame जो है that moves along different designated areas, and those areas, as I told you, that they are workstations. So the frame structure moves along different workstations. Workers are waiting there for the new frames, and as they arrive to their particular designated areas, so the worker start moving along the automobile frame, and they started assembly operations which are related to them on the frame structure. Uh, and after a particular interval of time, uh, those workers complete their task and then they go back to the start point of their designated area. So that is pacing with margin. और ये मार्जिन जो है वो ये होती है कि when a part arrives into a workstation, so the worker will be standing at the start point of his designated area. And as soon the workpiece arrives his area, so he will start moving with the base component, and also he will be performing the assembly operations on that basic component. So the part will move, the worker will also move along that part. And for example, again, I will say if the cycle time of the system is 1 minute, so in in 1 minute, the part will uh, arrive the finish line of that particular workstation, which will be assigned to a specific worker. So after that 1 minute, the worker must have completed his part of assembly operation. So after 1 minute, that worker has to go back to the start of the workstation. Uh, this particular time, when the worker reaches the finish line, and then he will go back to the start line of his designated area, that time is the margin which you should give to that particular worker. So this is pacing with margin. And this second figure shows the second discipline in which the product is moving, and as that product arrives a particular workstation, so the worker start assembling things with certain tools, and जब complete होगा, so they have to go back to the starting point. Third discipline is of no pacing. No pacing means that irrespective of the cycle time, if you have a random type of system in which uh, there are different workers and they are assemble things, and there is no discipline for the time. So if you are working in some designated area and the part arrives and you started assembling things on that, and you do not have any restriction of the time that you will have to complete this in 1 minute or 2 minutes or 5 minutes. So this is no pacing, ठीक है ना. So no pacing is basically no discipline, ठीक है ना. और ये फैक्ट्री लेवल पे आपको ये नहीं मिलेगा. So normally you will see rigid pacing or pacing with margin. Uh, as far as the product varieties are concerned, अगर एक से ज़्यादा प्रोडक्ट्स जो है वो एक असेंबली प्लांट में असेंबल हो रहे हैं, तो सिनारियो will be of either batch type of production or जॉब शॉप. जॉब शॉप के लिए असेंबली लाइन जो है वो आपको नहीं मिलेगी. सो इन मोस्ट ऑफ द केसेस इफ यू हैव वेरिएशन इन द product variety, so that will be batch type of setup. So with reference to those varieties, you may have single model assembly line, batch model assembly line, and mixed model assembly line. Mixed model assembly line is again batch model assembly line. But in batch model, independent batches will be assembled. For example, अगर दो batches हैं तो फर्स्ट बैच विल बी assembled. अगर आपने फॉर एग्जांपल 100 यूनिट्स जो है वो असेंबल करना है तो 100 यूनिट्स ऑफ फर्स्ट बैच विल बी completed, and then the second batch will be started. Mixed model assembly line में यही होगा कि these two batches will be assembled in a mix. ठीक है, like for example if first part coming out of the system is of batch number 1, so the second part may be of batch number 2. So if you are working in a mixed model assembly line, so that must be then full-fledged automated system. So it is basically sequential with reference to the batches, and it is non-sequential. It is a random process. So randomly you will be assembling different products simultaneously. So this is not in our course. So आपके जो problem होंगे assembly line balancing के कोर्स में वो सिंगल मॉडल असेंबली लाइन से रिलेटेड ही है. सो बैच मॉडल लाइन की जब आप बात करते हैं या मिक्स मॉडल लाइन की आप बात करते हैं तो इफ़ यू हैव हार्ड वेरिएशन इन हार्ड प्रोडक्ट वैरायटी, सो दे आर असेंबल्ड इन बैच मॉडल लाइन सीक्वेंशियली होगी, because in hard variation the type of operations are totally different from one batch to another batch. If you have soft variation within the product, so most of the operations will be similar. So simultaneously you can assemble then multiple products. And if there are no varieties, this means that it is a mass setup. एक ही टाइप का प्रोडक्ट बन रहा है, so you have no variation of the products, and normally it is considered as a single model line. Single model line means one type of product will be produced. Some of the definitions that you will come across with reference to assembly operations. So workflow जो है एक तो पेस का जो मैंने आपको बताया, each work unit should move steadily along the line, and that movement policy is with reference to the cycle time of the system, और उसको हम line pacing कहते हैं. So line pacing जो है it decides that the workers must complete their task within a certain cycle time, which will be the pace of the whole line. मैनिंग लेवल की बात होगी क्वेश्चंस में. सो एज द नेम एम्प्लाइज दैट मैनिंग लेवल is basically the total number of workers that will be designated to one workstation. And workstation, I told you that it can be assembly machine, it can be a worker himself, or it can be combination of both. So you might have an assembly machine, and a worker will be operating that particular machine. So anyhow, any designated area in which worker is assigned and he performs some assembly task, so that area will be designated as a workstation. So अब हर एक वर्कस्टेशन में जितने वर्कर्स असाइन होंगे that will be known as a manning level. So like in this picture you see a designated area for engine blocks, जहाँ पे इंजन की जो इंजन ब्लॉक्स है उनकी असेंबली हो रही है, and there are two workers working in this particular area. So the manning level is 2. So two assembly operators that are working on the engine assembly line. So इसका manning level जो होगा वो 2 होगा. So if the manning level is 2, this means that theoretically when you will go for calculations, So you will have to take that Manning level equal to 2 for each and every workstation on average, ठीक है ना. सो ये मैनिंग लेवल का जो फिगर होगा ये एवरेज बेसिस पे हम लेते हैं. यानी सपोज इफ द मैनिंग लेवल इज़ 3, so it will be considered that you will have 3 workers each on every workstation of that particular assembly plant. इंस्पेक्शन सेक्शन है ऑटोमोबाइल इंडस्ट्री का. यहाँ पे आप देख रहे हैं अगेन देयर आर 2 वर्कर्स, मे बी 3 वर्कर्स. नॉर्मली 3 वर्कर्स ही होते हैं. 2 वर्कर्स चेक द क्वालिटी एंड 1 वर्कर record those figures. So manning level, as I said, that there may be more than 1 worker per station. बाज़ औक़ात प्रॉब्लम्स में जो मैनिंग लेवल है वो रेशो में मिलेंगे. यानी 2 और 3 तो ठीक है, बट in some of the problems you may see that it will be given that Manning level is 1.3 or 1.4 or 1.5. Yeah. So 1.5 physically अगर आप देखें तो it is not possible to have 1.5 worker या 1.7 worker per station. So they are basically utility workers. So utility workers are those workers which are not directly assigned to specific workstations. They are responsible for these 3 tasks जो कि mention है. So they may help the workers who will fall behind. अगर for example कोई worker जो है वो slow जा रहा है, so the utility workers go there and they help them to achieve that pace of the line. You know, जो मैंने आपको कहा ना कि you will have a specific cycle time and you must have to complete your assembly operation in that particular cycle time. अगर for example कोई किसी वर्कर को पर्सनल ब्रेक की ज़रूरत पड़ती है, so normally the utility workers replaces them. मेंटेनेंस और रिपेयर्स का अगर काम आ जाए तो यूटिलिटी वर्कर्स विल बी देयर टू help the other workers. So anyhow, utility workers are those workers who are residing within the systems, but they are not directly assigned to the workers. You know, so any worker who needs assistance or who needs help, so normally the utility workers are available for them. You know, so for example, if you have a system and the total number of workstation of that system is 10 workstation, and suppose you have 1 worker per each station, so the total number of assigned workers will be 10. And suppose you have 5 utility workers, you know, so वो 5 workers होंगे, they will be residing within the system, and they will look for the other workers to call them. So in total now you have 15 workers in that particular assembly plant, but the assigned workers are 10, one each for 1 workstation. So the total number of workstations are 10 and the total number of workers are 15. अगर इसको आप रेशो देके तो normally the Manning level is calculated as the total number of workers divided by the workstations. You know, so total number of workers आपके पास 15 है और workstation आपके पास 10 है, तो 15 divided by 10 gives you 1.5. So that is why sometimes you will see a ratio of the utility workers at the Manning level calculation. So average Manning level normally अगर आप find करना चाहते हैं तो practically average Manning level जो होगा that will be इस स्लाइड को मैं कंप्लीट कर लूँ तो यू विल सी नॉर्मली अगर आपने मैनिंग लेवल कैलकुलेट करना हो तो मैनिंग लेवल इज़ बेसिकली द वर्कर टू मशीन रेशो यू नो सो जितने वर्कर होंगे उसको सिंपली आप मशीन्स पे डिफाइन या वर्क स्टेशन पे डिवाइड कर ले तो इट विल गिव यू द मैन लेवल मैनिंग लेवल के हर एक मशीन पे कितने वर्कर होंगे so W is worker and N is number of machines so in normal cases if there is no utility worker so simply आपने calculate करना होगा W by N से if the utility workers are there so then वो utility workers भी आपने add करने होंगे जो assigned workers हैं उनके साथ so that will be the utility workers. So W with the prefix U represent the utility workers, and WI are the workers who will be assigned to station I, and station I may be from 1 to n. Like for example, if you have, as I gave you the example first, that if the total number of workstations are 10, so in that case I will be equal to from 1 to 10. So you will have 10 workers assigned to the workstation plus the total number of utility workers, suppose if they are 5. So 5 plus 10, 15 divided by 10. आपके पास चूँकि नंबर ऑफ वर्क स्टेशन जो है वो 10 है तो डिवाइडेड बाय 10 सो इट विल गिव यू 1.5 सो फिर आपने ये फार्मूलेशन जो है वो अप्लाई करनी होगी सो मैनिंग लेवल in case of utility workers will be the workers that will be assigned to the workstation plus the utility worker also okay? And then you have to divide it by the number of workstation वर्क ट्रांसपोर्टेशन स्कीम जो है असेंबली लाइन में मैनुअल भी हो सकता है इट कैन बी मैकेनाइज्ड वर्क ट्रांसपोर्ट सिस्टम्स मैनुअली अगर आप परफॉर्म करते हैं यानी जो कन्वेयर सिस्टम है या जो मूवमेंट पॉलिसी है इफ इट इज़ अ कन्वेंशनल सिस्टम अ मैनुअल सिस्टम सो manual methods means that the work units will be moved between stations by the workers using some mechanical mechanism जो कि कन्वेयर भी हो सकता है जो कि हैंड कार्ड्स भी हो सकते हैं और पावर्ड कन्वेयर भी हो सकता है मैनुअल ट्रांसपोर्टेशन स्कीम में ज़्यादातर ये प्रॉब्लम जो हमने डिस्कस किए थे पिछली वीडियो में स्टार्विंग या ब्लॉकिंग का जो फिनोमेना है वो आ सकता है तो starving of stations if the assembly operator has completed the assigned task on the current work unit but the next unit has not yet arrived. That was discussed in the previous video. And blocking is a phenomenon in which a worker will complete his task but he will not be able to pass on it to the next workstation. To reduce starving, we can use buffers, and to prevent blocking, we can provide an extra space in between the current and the upstream या जो डाउनस्ट्रीम स्टेशंस हैं उनके बीच में जो स्पेस है वो अगर हम ज़्यादा कर लें सो वी कैन अकोमोडेट मोर number of work pieces but they are not परमानेंट सॉल्यूशंस या टेम्परेरी सॉल्यूशंस ही हैं लेकिन और परमानेंट सॉल्यूशंस के लिए आपने जो है वो फिर मैथमेटिकल इक्वेशंस की तरफ ही जाना होगा ठीक है ना सो दिस बोथ सॉल्यूशंस विल रिजल्ट इन अ हायर वर्किंग प्रोसेस मींस वर्किंग प्रोसेस मैंने आपको बताया हुआ है several times that those work pieces which will be present within the system during the run time of the plant they will be considered as the work in process. ठीक है ना. So work in process वो वर्क पीसेस जिनका जो प्रोसेसिंग जोन में हो, जो वेट कर रहे हों, जो कन्वेयर पे मूव कर रहे हों, जो लोडिंग और अनलोडिंग के फेज़ में हो. सो एनी वर्क पीस विच विल बी present within the system will be considered as the work in process. ठीक है ना. सो अगर आप बफर्स यूज़ करते हैं, अगर आप जो है वो एक्स्ट्रा स्पेस प्रोवाइड करते हैं, तो इसका मतलब यही है कि यू आर इंक्रीजिंग द नंबर ऑफ वर्क पीसेस, है ना. सो if you increase the work in process, this means that the waiting time will be more. सो असेंबली लाइन बैलेंसिंग का जो प्रॉब्लम है, उसमें आप ये चीज़ें जो है वो चेक करेंगे. सो नॉर्मली योर पर्पस ऑफ असेंबली line to balance them will be to equalize the workload among the assemblers. So normally, if you have multiple assembly operations on an assembled product, so each operation will have a different processing time or assembly time, you can say. And it is not possible basically to evenly distribute those operations among the workstations, or you can say among the workers. So definitely there will be time differences between the workstations. Uh, what we do in line balancing is that we try to level or to reduce those differences in between the workers or in between the workstations. So normally your task will be to equalize the workload among the assemblers. You have to distribute the workload among the workers in such a way so that you have the minimum differences in the operational times of the workstations. For that, you will have to identify the bottleneck operation. Bottleneck operation जो है मैंने आपको बताया था कि it will be the busiest workstation of the system, or you can say अगर busiest है तो it will be the slowest workstation. Slowest or busiest workstation means that workstation who will have the maximum processing time or assembly time. So first you will have to identify the bottleneck operation, and then it will decide the speed of the assembly line. And when you come up with the speed means the cycle time. So if you have the cycle time, then you will be able to calculate the number of workstations, and then you will also be able to determine the labor cost of the assembly. You have to establish the percentage workload of each operator. So अगर आपने even distribution करनी है, so this will be your task to assign the load to the workers. So you will have to establish that percentage workload, that how much load will be assigned to a specific area. You have to assist in the plant layout. So when you have that distribution, so that distribution will then definitely make a plant layout. So जो distribution आप करेंगे, so that distribution will give you the sequence, and once you get the sequence, so that sequence will be basically the plant layout. It eventually becomes the plant layout. And of course, your main desire will be to reduce the production cost. सो व्हेन प्रोडक्शन कॉस्ट आप इसी तरह ही रिड्यूस कर सकते हैं कि अगर आप जो टाइम डिफरेंसेस हैं वो कम से कम कर सके, जो वेटिंग टाइम्स है अगर आप वो रिड्यूस करते हैं, सो दिस मीन्स दैट यू आर रिड्यूसिंग द प्रोडक्शन कॉस्ट्स. The assembly line balancing technique usually builds on the assembly chart, time standards and takt time. सो असेंबली चार्ट आपके पास होगा, यानी जो प्रोसेस प्लान होगा, उस प्रोसेस प्लान में आपके पास जो मशीनिंग टाइम्स हैं इंडिविजुअल वर्क स्टेशन के वो फिर होंगे, और आपके पास टैक टाइम होगा. टैक टाइम मीन्स द साइकिल टाइम. So sometimes in some books you will see the takt time. So takt time हो या साइकिल टाइम हो या प्रोडक्शन रेट हो या पेस की आप बात करते हैं, तो ये बेसिकली साइकिल टाइम ही होता है. ठीक है ना. सो टैक टाइम जो है वो इट इज़ नॉर्मली कैलकुलेटेड इन मिनट्स पर पीस, जिस जो कि आपका प्लांट रेट ही है, ठीक है? या पीसीस पर मिनट. So as far as the cycle time is concerned, so as I told you that you will have a specific amount of time, and each worker has to complete his work or his task in that amount of time. So a cycle is the amount of time that a work in process unit can stay in a particular workstation before it must move on to the next workstations. And at the end of every cycle, each station will hand its work in process to the next workstation. Yeah? So अगर for example 5 minutes है, तो after 5 minutes each worker will hand over its work in process to the next workstation, और आखिरी workstation से जो है वो आपका finished product जो है वो बाहर निकलेगा, which will be inspected, and then it will move on to the storage area. So suppose if the cycle time is 10 minutes. So if the cycle time is 10 minutes, so this means that each station would hand its work in process over to the next station at the end of each 10 units. So हर 10 minutes के बाद the station one will switch its part to station 2. station 2 से जो है वो station 3 पे जाएगा, और station 3 से जो है वो warehouse की तरफ जाएगा. So if you have 3 stations, let us say, within the system, and the cycle time is 10 minutes, so this means that each worker has 10 minutes time to complete his task. So if you look into the product, you have one product. So the part will first move on to station number 1. It will be processed for 10 minutes. Then it will move on to the next station. 10 minutes यहाँ पे task operation होगा, और 10 minutes जो है वो यहाँ पे होगा. So the total time of assembling this particular product is 30 minutes. ठीक है ना, वो 30 minutes है. सो अब अगर आप साइकिल टाइम की बात करते हैं, तो although product is completed in 30 minutes, but after each 10 minute you are getting one product out of this system. This is because that 30 minutes time has been distributed among 3 workstations. ठीक है ना. सो जो आपका टोटल वर्क कंटेंट है वो 30 मिनट्स का है, लेकिन इंडिविजुअल एलिमेंट्स की मैं बात कर रहा हूँ. सो जो वर्क एलिमेंट्स हैं दे आर ऑफ 30 मिनट्स, बट द टोटल वर्क कंटेंट is completed in 10 minutes. So the cycle time, or you can say the production rate of the system, is uh, one piece या one part per 10 minutes. ठीक है ना. सो हर एक 10 मिनट के बाद जो है वो आपके पास एक पार्ट जो है वो बाहर निकल रहा है इस सिस्टम से. असेंबली लाइन बैलेंसिंग की जब आप बात करते हैं, तो नॉर्मली व्हेन वी से दैट you will have multiple stations and you will have to distribute the workload evenly among those workstation. So evenly का मतलब ये है कि we try to come up with a perfect balance assembly line. Perfectly balanced assembly line का मतलब ये होगा कि each and every station will have the exact amount of workload that will be equal to the cycle time of the system. So for example, अगर let us say यही जो एग्जांपल हमने डिस्कस किया कि there are 3 workstations, and let us say total cycle time of that system is 10 minutes. So this means that each workstation will have 10 minutes to complete his task. Suppose you have multiple tasks from task A to task F, ठीक है ना, आपके पास टोटल लेट से 6 ऑपरेशंस है, A B C D E F, and you have 3 stations. So you will have to assign those operations to these 3 workstations. So let us say जो टास्क ए है यानी जो ऑपरेशन ए है, इट्स प्रोसेसिंग टाइम इज़ 10 मिनट्स, टास्क बी का जो टाइम है वो 5 मिनट्स है, टास्क सी का जो है वो 5 मिनट्स है, डी इज़ 2 मिनट्स, टास्क ई इज़ 3 मिनट्स, टास्क एफ इज़ 5 मिनट्स. सो इन टोटल अगर आप देखें तो it is more than 10 minutes. So you will have to distribute them among those 3 stations. Okay? And your cycle time is 10 minutes, so each station has 10 minutes of time. So you can, task A can only be assigned to a single workstation because its operation time is 10 minutes, so you cannot exceed 10-minute time for each any of the station, ठीक है ना. सो अगर स्टेशन 1 को लेटर से आपने टास्क ए असाइन कर दिया है, तो दिस मीन्स दैट यू कैन नॉट असाइन एनी अदर टास्क. वी कैन असाइन, हम असाइन कर सकते हैं. फॉर एग्जांपल अगर टास्क बी जो है वो मैं यहाँ पे असाइन कर दूँ, सो टास्क बी हैज़ 5 minutes processing time. So now this means that station A will be, or station 1 will be busy for 15 minutes. अगर 10 मिनट्स ये है और ये भी आप इसको असाइन कर दे, तो 15 मिनट्स मीन्स दैट योर साइकिल टाइम will be increased to 15 minutes because after each 15 minutes you will get a part from station number 1. So if you increase the cycle time of the system, this means that you are decreasing the production rate of the system, because production rate means per unit time, ठीक है ना. So प्रोडक्शन रेट जो होगा वो 1/साइकिल टाइम ही होगा, ठीक है ना. जब आप पर रेट की बात करते हैं तो प्रोडक्शन रेट मींस रेट इज़ पर यूनिट टाइम. पर यूनिट टाइम इज़ द साइकिल टाइम बेसिकली. So if you increase the cycle time of the system, this means that you are decreasing the production rate of the system. So that is why if you say that the cycle time is 10 minutes, so it has to be 10 minutes. You cannot increase that time, you know, because the cycle times are normally designed on the basis of the demand rate. कि डिमांड आपको क्या मिल रही है, बिकॉज अगर एक कस्टमर की तरफ से ऑर्डर आता है तो ही विल हैव सर्टन डिमांड, और वो उसके लिए एक स्पेसिफिक टाइम जो है वो आपको दिया जाएगा. सो स्टेशन नंबर 1 को आप सिर्फ टास्क ए ही असाइन कर सकते हैं, विच इज़ 10 मिनट्स. स्टेशन 2 को अगर आप देखें तो फॉर एग्जांपल इफ़ वी असाइन टास्क बी विच इज़ 5 मिनट्स, सो दिस मीन्स दैट वी स्टिल हैव 5 minutes idle on station number 2. So there is another task which has 5 minutes time, so वो भी आप असाइन कर सकते हैं. एंड सिमिलरली स्टेशन 3 को अगर आप देखें तो टास्क डी जो है वो 2 मिनट्स का है, फिर एक तीसरा टास्क दिया गया है जो कि 5 मिनट्स का है, और टास्क ई जो है वो 3 मिनट्स का है. एंड इफ़ यू एड देम, सो 5 + 3 8 + 2 10. सो एग्जैक्टली हर एक वर्क स्टेशन का टाइम अगर आप देखें तो इट कम्स आउट टू बी 10 units, ठीक है ना. So you have 10 minutes productive time at station 1, 10 minutes productive time for station 2, and 10 minutes productive time for station number 3. So in total you have 30 minutes of total productive time, you know? So when you assume that the cycle time of this system is 10 minutes, and if you look into the losses, so yeah, idle times की जब आप बात करते हैं तो you have no idle times in this particular system. So if the case is like this, in which your distribution is such that all the workstations are exactly performing the operations in the same time, so that will be a perfectly balanced line, and practically it is not achievable. Definitely you will have idle times in between the or among the stations if you have multiple stations, you know. So a perfectly balanced line will never be achieved, you know. Loading or unloading time different होंगे, movement policy different होगी, operation time different होंगे. So there are so many factors due to which it is impossible to come up with a solution in which you will get a perfectly balanced line, you know. So your solution will be something like that, you know. So normally tasks जो है they are measured in seconds or minutes, and they will vary from one another, and it is impossible to assign tasks to all the workstations so as to get the exact work times at each station. So therefore a perfectly balanced line does not exist, ठीक है ना. So आपके पास कुछ इस तरह का solution आएगा, ठीक है ना. Like you will have multiple stations, and suppose the cycle time is 10 minutes, so maybe task A जो है वो 9 minutes का होगा, टास्क बी जो है वो 4 मिनट्स का है, टास्क टी 4 मिनट्स का है, 5 to 2 का है, you know. So your solution will be something like you will have a productive time uh, of workstations which will be nearly equally merely equal to the exact cycle time, you know. Maybe हो सकता है कि एक दो स्टेशन ऐसे हों जो कि एग्जैक्टली जो साइकिल टाइम है वही टाइम जो है वो मशीनिंग टाइम भी बन जाए, but for most of the workstation you will have some productive time, and there will be certain idle times also, you know. So for example अगर station 1 है and the operational time is 9 minutes, so this means that there is a 1 minute idleness for station number 1, you know. So you have a 1 minute idle time over here. Similarly, for this station, you will have some productive time and some idle time. You know, so overall, you will have some total productive time, and you will have some total lost time as well. Again, these figures are exaggerated figures. Normally, इतना difference आपको नहीं होगा. They will be in seconds, but still, there you will see if they are in seconds, so it will affect the production rate of the systems. And now in the next video we will be starting with the analysis of the single model assembly line, which are the line assembly problems.